Okay, welcome back to another episode of Programming Screeps. So this time let's actually switch to a private server. So private servers can be found, you can either launch the game and it has a pop-up on Steam, a dedicated server button, or you can download this, to follow this page on GitHub, where you use npm to install the Screeps private server and then do these steps. These steps will prompt you for the Steam WebKey API, which I've already done, since that's secret, and then you can, on a command line, run Screeps start. And you can give it a number of runners, number of parallel worker processes to launch. Don't set it greater than the number of cores, and number of processors count. Processor worker processes to launch. So I set both of mine to 4, just for the heck of it. And the only other thing I did was I installed a mod called this one, Screeps mod tick rate. This is a server admin mod that lets you set the tick rate, which basically allows your private server to run faster, which is pretty useful for just basically what you saw in the simulation last episode, where you're able to make the game run really quick. The bad thing is it doesn't show you visually, but it does work. You can also get through it if you use the Steam Workshop version and you're launching the dedicated server through Steam. You could subscribe to this one, which is the same thing. Now, when I did this command, the only thing I noticed is it doesn't automatically add it. For me, when I went into my server folder, my mods.json was not modified. So what I did was, or I guess what I should do is let's modify this, and you have to put this line in there. And I found this line by using the Steam version. This will basically index or give a reference to you load up this this mod. So let's go stop the server and then launch it. And now what you can do on another command line is you can go to the server and type what is it? Screeps CLI to get to the command line interface. So now you can do this set tick rate to, let's say, 1,000. Yeah, there we go. Now tick rate set to 1 second. I'm not sure what the default is, but it's something around a second, maybe 5 seconds. Well, I guess the default in shard 1 is 2 seconds. Shard 0 is 4 seconds, which is pretty slow. So 1 second's pretty good, but you can set it really quick. So we'll see that in a second. Then what you do back in the game is you say change server, and then you just connect to localhost, this crazy number, which is automatically set. Click connect, and then you're connected to the server. So I'm going to type my name, Cardi Snoopy, and not use an email because I don't need to do that. Then click register. And you give it some random badge, doesn't really matter. And then it says, okay, now you're on your own Screeps private server, and you can change all this stuff, which is pretty sweet. And you have like your own little world, and you can make it bigger if you want, but it doesn't really matter since this is all kind of simulation stuff anyway. I'm not actually going to allow other people to connect to this one. This is all just for me, like to test my code because the simulation itself has a lot of limitations. You're only allowed one room, but this thing you're allowed to basically play the whole game. Now this does have 4 bots automatically attached to it. I don't think the bots are that aggressive. I haven't really played this thing very much. But anyway, let's just start in this room, which has kind of 2 nice spawns, or 2 nice energy fields. Put the spawn like right up here. And there we go. So now we got nothing in terms of code. But you can click this button, open local folder, and this will jump you to a spot where your code is. You can say okay. So now you have this is where you can put your code. So I'm putting all my stuff on GitHub for those that are following along. So if you go to github.com/KarateSnoopy, there's a Let's Play Screeps sub repo, and in there is what I'm going to be doing. So I'll try to put different branches up. I'm just going to do Let's Play Episode 2. That's what I'm showing you off in this episode, because we're on Episode 2. So let's take a look at what I'm doing here. So I'm using Visual Studio Code. It's a free Visual Studio kind of app from Microsoft, and it's pretty good for messing with JavaScript and TypeScript. So basically I just did a file open folder, and I opened my Let's Play tutorial folder, and here's all the files. So these files are actually the same files I tried to basically just copy paste what the tutorials gave me. I also have a temp.txt, which is kind of the extra stuff that tutorials kind of said to do in the command line up here, and this random tower thing that I didn't bother kind of putting in. So whatever. Alright, so let's see if I can deploy this. Now what I did do was make a simple script. Let's go back in my Let's Play folder. I made a simple go.script, which basically just does robocopy from the tutorial folder to my local private server folder, and that should just copy all the files over. So now if we go back over here in my private server folder, all the files are there. And if I go back to my game, now all the files are there. Pretty sweet. And then you can see it's already starting to run, because as you saw before, it just has auto spawn code for the harvesters. Alright, so you can basically see the harvester moving every second he's moving down. But what's sweet is now that we're on a private server, I can go over here and change it to 100 milliseconds. So now you'll notice that the game's visuals don't update that fast, but the tick rate is definitely a lot faster. If you notice here, it's like jumping by 10s. And you can actually make it jump by 20s, like you can make it 10 milliseconds. And there's a limit on what it'll do, but so if you set this to like 5, to spawn 5 dudes, you see they're all flying. Now I'm not really a fan of it moving this quick, because it's kind of ridiculous. So I'm just going to set it to maybe 500 milliseconds. Probably is good. I don't know. We'll play with it. Alright, so now I got 5 harvesters. And let's see. I can probably build extensions, huh? Or I probably need a controller guy. Let's go back in Visual Studio Code. Go to my temp.txt. And let's create a upgrader, is what it's called. Let's go build one of those guys manually. And he'll go upgrade the room. And I think this upgrader code is like super busted, because it doesn't have kind of any good logic to it. So he's only got like 2 energy. So we'll fix that later. I'm not going to bother fixing it right now, because I want to move to TypeScript pretty soon. I'm just showing off the code that was in the tutorial, kind of in a Visual Studio Code way, because obviously you don't want to use this as an editor. This is a really bad editor. Visual Studio Code's a lot better. So if you want to work in JavaScript, this is kind of a good base to kind of get started with. I don't really recommend using JavaScript though, because JavaScript doesn't have any type safety, and that's what TypeScript's all about, giving you type safety. So JavaScript won't give you any compile errors. You just have to kind of run it, and then if it eventually gets to the line and then there's an error, it's going to yell at you, which is really annoying, and it's really hard to refactor code and so on. So I'm a pretty big fan of TypeScript. Of course, like I said in the last episode, I'm not a professional JavaScript or TypeScript programmer. It just seems to me TypeScript's type safety is really nice. I am a professional C++ and C# developer, or C# developer though, however. So even though I don't know I'm no expert at TypeScript or JavaScript, I can figure it out by looking it up. Anyway, let's make a builder guy and like see him work as well. So we need to go. How do we build? It's been a while since I used this game. Let's see, invasion, display options, world map, world, room overview. There's a way to manually place a construction object. Create invader. It's not what I want. Okay, so you click up here, create flag, construct. So up here you have all these different things you can do. So this says you need, to make an extension, you need room level 2 to do that. So we'll mess with that later. Alright. That's pretty much as far as I want to go with TypeScript. Let's switch over to, as far as I want to go with JavaScript. Let's switch over to TypeScript, because that's a lot better in my opinion. I just wanted to show that this is the path, show a path through with JavaScript. Alright, let's switch back to master, because currently it's using my TypeScript stuff. Let's play episode 2B. Let's do episode TypeScript actually. Alright, push that branch. Alright, so the master branch I've already previously set up with, show you how I got that. So if you go to GitHub, there is this guy here. Let's see who did this. This guy, Rezer014, made a starter kit for TypeScript-based Screeps AI, which is pretty sweet. And he made it based on this original starter script, which I think I used a long time ago. Anyway, this one's pretty nice. So I basically did the setup on this, installed Yarn, and got this set up. I didn't bother setting up the credentials since I'm just doing the local stuff, but I imagine the credential stuff works to do online play. And then once you get it working, then you can do 2 different modes. And here you have a, you can either npm run watch local, or you can do npm run local. So npm run local will, in theory, let's see. Because I deleted I didn't check in, of course, the node modules, so you have to do yarn. You have to just run yarn again. And that will install all the, once you download this stuff, you know, if you're following along, you run yarn and that will install all of the node modules guys in there. So then in theory you can do npm run local. And then you'll see it compiles everything, and if all goes well, it should say it's happy. And looks like there's a code bug here, just a lint bug that says triple equals. But anyways, so that's a one-time build. You can also use this go.cmd, which I set up, which does a watch local command. And that's kind of nice too, because all you do is you open it in Visual Studio Code like we did before. So let's go open folder, and let's open just our Let's Play folder. And then you have this source folder set up with basically Very similar code to what you see inside his folder. I did rearrange it just a little bit because it's I kind of flattened it out. So in his folder, he has a bunch of subfolders. So I just basically moved this guy into lib, and I moved the config to the root, and then the stuff in here and here I just put in the root as well. So basically everything's in the source folder except for the lib directory, and the lib has a logger guy. I also in the lib directory added a profiler guy, which is part of the pull request here. It's not yet accepted, but this pull request basically jumps it to a new profiler as described here. It's a new Screeps TypeScript profiler, which seems to work pretty well. I had some issues trying to get it set up, but I talk about that in the pull request. So if you're so inclined, you can go check that out, but whatever. I'm not going to get to profiling for a while probably, but just for fun. Anyway, so now let's go check out, let's see if our game's still alive. So now what this guy does is he makes, Screeps doesn't understand TypeScript, of course, but it does understand JavaScript. So if you go look at what happens here, if you delete these files and you go run, and you go run this guy again. So when he goes and builds, he will deploy these two JavaScript files, a main.javascript and a main.javascript map.javascript. And those two files have, get rid of all this crap, and from Notepad++. Are basically a JavaScript version of all the TypeScript. And this crazy map file has a map that maps it back to the TypeScript. So the good thing is when it starts logging, you'll see what TypeScript file it came out with. So mainly you just kind of ignore these JavaScript files, and you mainly work out of Visual Studio Code. So you can, like, let's say log.info test, something like that. And I just click save. So the sweet thing is I just saved it in Visual Studio Code, and this watcher guy automatically rebuilt the files and automatically copied them to this directory. And now you can see, okay, in main source main.test, or TypeScript, line 25, there is this line I added. So there you go. And let's go fix that one small bug. Let's see, in Script Manager, line 93 should be like that. All right, there we go. I'll move that. I don't really need that, so I'm just going to close that. And this also has Git built in, so you can mess with Git. Fixing bug. No staged, automatically always, sure. Reversible, I haven't messed with this UI yet. Push. Okay. I guess it's pushed up. Very exciting. Yep. There's our fixing bug commit. How exciting. All right. So let's take a brief tour of what this code is before we start ripping it apart. So we have our main loop here, which is I put into a main.go to try to get this profile stuff working, but you don't really need it. Because the profiler, for anybody that's curious, this profiler over here, it says to use it, you basically use this decorator, this guy, and you do @profile. And when I try to do it, like if I go do it here, if I put this guy here, and then import the profile guy, he's going to give me an error. At least last time. Well, he won't give me an error because I moved it into a main, but it doesn't get called. Like it just doesn't. It does not profile, and I don't really understand why. And then if I put it over here, it will give me an error. So it says like decorators are not valid here, and I don't understand why decorators are not valid here. Which is pretty weird, because it sure seems like it should be. The one way I did find it, I could call the profiler, was basically kind of doing this. So getting a, that's actually not this one. Let me get rid of that. By doing this. So I made a simple helper function called profile record inside the profiler TypeScript file, which says, okay, if it's enabled and the start boolean is true, then record the get used. Otherwise, record the get used and then minus the end versus the start and call the original chord key. And the key is some string you pass in. So I just kind of splatter that between the two functions I want to record. Not the most elegant solution, but it does work. The original way this profiler stuff is supposed to work is it's supposed to use this decorator stuff, which is here. And it's supposed to basically, it's here, inside this wrap function. This guy calls wrap function. And it's supposed to do this reflect set stuff, but this never gets called. I did a bunch of logging to try to figure out what the hell is going on, but I couldn't figure out why this wasn't getting called, so it wasn't really worth my time to fix it. I'm sure somebody smarter than me will go figure it out, but in the meantime, this works. So now you can, to see profiling, you can actually go back to the game and you can do profiler. Let's see. Say profiler.start, and then you can do profiler.output, and you can see the 3 functions I wrapped. So there's been 9 calls to load creeps, 9 calls to building creeps, 18 calls to harvest or run. Here's all the tick stuff and the percent of total. So pretty basic stuff, but it's a nice profiler once you get into it. And you can, of course, turn it off with stop. And you can clear it with .clear. So it'll forget everything. So then when you do output, clear, stop, clear, output. So now it doesn't remember anything. Anyway, so let's take a look at what's going on with this thing. So this basically says, okay, there's a unique user ID greater than 100, so it stops it at 100, which I guess is fine. So it's 0 to 99. I think I'd probably rather prefer that 1,000, just to be safe. All right, so there's game rooms. So loop through all the game rooms. So now you have a room, and then run the creep manager on the room. And then look at all the memory, and if the creep is in this room, and there is not a creep with that name, why is it doing that check? Like, does it even matter? It's kind of weird that it does this check, and it does this check inside the room. This is kind of weird code. But anyways, it deletes the memory from that creep, for the dead creep. So we'll fix that up later. This is a TypeScript kind of GUI that overrides the global interface, because global is kind of like a property bag that you define yourself. So he's added into the memory interface, he's added UUID, log, and profiler, and he originally named it P, but I renamed it profiler. Harvester, we'll get that in a second. Config.ts, this is kind of where you set all your config stuff. Like if you're in debug mode, that's basically a bunch of debug logging. I don't think I use this one. Yeah, I don't even use this one. Let's just get rid of that one. And I don't think, yeah, I got rid of the code that does that one, so I'll delete that one too. No reason to have ones that don't use it. There's a bunch of logging kind of defines, so we'll leave all that be, because there's a bunch of logging code that doesn't really matter. Alright, and then there's Creep Manager. Creep Manager, this is kind of like a room manager, where it says, okay, load the creeps, build the missing creeps, and then for each creep, switch on its role. So loading creeps says, okay, room, find all my creeps, get a count, and find all the harvesters in an array. And then build missing creeps says, okay, find all of the, find all my spawns are spawning, and if it filter out to the ones that are not spawning. If it is spawning, then filter it out. So this only returns guys that are not spawning. Okay, so now you have a list of spawns that aren't spawning. And then it says, okay, look through if the number of harvesters we detected earlier is less than 2, then if we have less than 1, and we have less than 800 capacity available, then build a work, carry, move guy. And if you have greater than 800, then build this guy. And then now it tells each of the spawns, which is kind of strange, to go spawn that creep, which in turn says, okay, go get a UUID, which it adds 1 to, and then it says, okay, spawn, can you build this creep? And if you can, I'm not sure why it does this is string status thing. Kind of weird. Maybe this guy returns a string too. Then name it based on the room, plus a role, plus a UID, which is kind of nice. So it gives it a nice name. And then it logs out some stuff, and then it tells it to go create a creep. And then it returns that. And then it says failed if it failed. No problem. And then that's build missing. And then harvester run is kind of your simple run logic, which says find your spawn, find your energy source. If you're at carrying capacity, go drop it off. Otherwise, go move and harvest. So it's trying to harvest, and then it kind of just does too many helper functions, because this is kind of just, this function's silly, because it's just this function. It's like it's wrapping too much, but we'll fix all that later. All right, so that's all the logic. This is all kind of code we saw in the tutorial, but just written weirdly. And this is an A* function that's inside, came with the project. I haven't used this, but I guess it is it might be faster than the current one built into the game. I don't know. I haven't tried it. A* is a pathfinding algorithm. And this is the profiler code from that submodule, or from that Get It repo. And this is a bunch of logger code. This logger code does all the kind of pretty logging stuff. So we won't look through it, but it seems to work well, so we'll leave it alone. And there you have it. There's a tour of the starting point of our project. So I will push that up on GitHub, and then next episode we'll start typing. Let's see, add. Let's see, actually we need to fix this. So main.ts, there's a bug here. Profiles declared but never used. Get rid of that. All right, so there we go. All right, so we're back to business. And there we go. So next episode we'll start from here and we'll build on this. Thanks for watching. See you next time.